Lecture 3.1, How to See Nanoscale Objects. The nanoscale ranges from 1 to 100 nanometers, where objects are too small to be seen with the naked eye, or even with ordinary optical microscopes. Hence, to study nanomaterials and nanostructures, specialized techniques and instruments are required. Understanding these tools is fundamental in nanotechnology. The question is, why can't we see nanoscale objects with our eyes? Actually, resolution of human eye is approximately 0.1 mm, that is 10 raised to minus 4 meters. Means we can see the objects as small as the size of 0.1 mm. Our vision is limited to the visible light wavelengths, that is 400 to 700 nanometers. And objects smaller than this wavelength range cannot be resolved by human's eye. Therefore, advanced microscopic techniques are needed. We use microscopes to see very small objects. They are precise scientific instruments designed to produce highly magnified, detailed images of objects too small to be seen by the naked eye, such as biological cells, microorganisms, and tissues. Commonly, in our science labs, we use optical microscope to see small objects. An optical microscope works on the principle of magnification using visible light and glass lenses. Its working principle involves three basic steps. Initially, light from a source is focused on the specimen through the condenser lens, which further passes through the specimen and is focused by the objective lens to form a magnified real image. This image is further enlarged by the eyepiece, producing a highly magnified virtual image that can be observed by the eyes. Now, what are the limitations of optical microscope? Actually, optical microscope can resolve the image of object of minimum size of 200 nanometers, and objects smaller than this size cannot be seen by the optical microscope. Whereas the nanoscale objects are in the size ranging less than 100 nanometers. So optical microscope cannot clearly image nanoscale objects. They are useful only for microscale observations. Therefore, electron microscopy is applied for working and seeing at the nanoscale. These microscopes use electron beam instead of light rays and can image nanoscale objects. Actually, electrons have much shorter wavelengths than visible light, enabling much higher resolution. Hence, to see even more smaller objects, special type of microscopes are used, like scanning electron microscope, that are known as SEM, and transmission electron microscope, TEM. Another important technique used in nanotechnology is scanning probe microscopy. The scanning probe microscope does not use light or electron for imaging. It uses a sharp probe. In scanning probe microscopy, a sharp probe is used to map the topographic features of the sample surface accurately. This is done by physically scanning a probe over the surface while maintaining a constant probe sample distance by force feedback. The example of scanning probe microscope are atomic force microscope, AFM, and scanning tunneling microscope, that is STM. Other important techniques used in nanotechnology include near field scanning optical microscopy, which breaks optical diffraction limit. Then we have X-ray diffraction, XRD. It gives structural information about the material at atomic scale. Then we have spectroscopic techniques, which combines imaging along with the chemical analysis of the material. Here is the comparison of basic features of major nanotech techniques. We can conclude this discussion in few major points such as seeing nanoscale objects requires advanced microscopy techniques beyond conventional tools. Electron microscopes and scanning probe microscopes are the backbone of nanotechnology research, allowing scientists to explore and manipulate matter at the atomic and molecular levels. Thank you for watching. See you in next lecture. You can find lot of content on nanotechnology on my YouTube channel PHYSIFER, where nanotechnology and science is explained for general common people who are not from the science background.